Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers, so that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got X on both sides, so we look at the X's. We've got 12X and 6X, so we always take away the smaller amount. So we're going to take away the 6X both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got X is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for X? Now, it is tempting to write down 10, but it says X has to be less than 10. So the biggest number we can get that is less than 10 is 9. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So when you look at this graph, it looks like it's going down as well as up. So it goes down to start off with, and then it starts going up, but then it starts going down again. And when you're looking at trends, you're looking, generally speaking, what's happening with it. So if you kind of draw a line to represent roughly where the graph is going, that line is going to go up. So the general view on it, the general trend, is that it is increasing. So you can write general increase in emissions. There are 2 rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin. So A and B cannot be in direct proportion. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's a million. So we times it by a million. So 13 kilometers squared is going to be the 13, and then it's going to be times by a million. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18, and the x value is the w value. So w is 18. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put a cross there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be minus 4, 1. So angles on a point add up to 360. And we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So first thing to realise is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497,069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same, so we're going to keep that as the volume, 1497,069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared, and we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. We don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that would be 141.11. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power of 4 times 13 times x to the power of 4 times y to the power of 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it. So I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by -3, because they're minusing 3 each time. So we know that the number before the n is going to be -3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3 and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the -3n. So it's going to be add 20. So our answer is -3n plus 20. So the distance initially travelled is going to be 14 kilometres for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometres travelled. So in total, there has been 28 kilometres travelled. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier. And the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So we're going to start by doing a grid, a multiplication grid, and we're going to start by putting 2x plus 11 at the top and 5x plus 3 down the side. and we're going to multiply them out. So 5 times 2 is 10, so it'd be 10x squared. 5x times 11, so 5 times 11 is 55, so it'd be 55x, and it's positive. And 3 times 2 is 6, so it'd be 6x, and that's positive. And 3 times 11 is 33, and that'd be a positive. So when we put them all together, we get 10x squared plus 55x plus 6x plus 33. You can see that the x terms are like terms, so we can add them together. So we get 10x squared plus 61x plus 33. So our answer will be 10x squared plus 61x plus 33. So asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA, and so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in, and we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around, up until this point, is 270, because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. It doesn't look like it, but we actually have a quadratic here, and the reason it doesn't look like it is because we don't have an x term, but as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we'll just go quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A. And so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. As with any question to do with adding fractions, you can only add them if the denominators are the same. So having a look at the first denominator, which is 3, and the second denominator, which is 2, we've got to find the lowest common multiple, or the lowest number that 3 and 2 are both factors of, and that's obviously going to be 6. So what I'm going to do is I'm going to times the top and bottom of the first fraction by 2. So we'll end up with 2 brackets x plus 5. And we're going to do the same to the bottom, times it by 2, which is 6, which is good, because we want them both to be 6, times the top and bottom of the second fraction by 3. So we've got 3 brackets x plus 9. And the bottom will be 6. Now with the bottoms being the same, the denominators being the same, we can just add the tops, simple as that. So we can have 2 brackets x plus 5 plus 3 brackets x plus 9. All of that over 6. Let's expand and simplify. So 2 times x is 2x. 2 times 5 is 10. 3 times x is 3x. 3 times 9 is 27. Again, all of that over 6. 2x plus 3x is 5x. 10 plus 27 is 37. And that's all going to be over 6. Have I simplified as much as I can? Well, 5x and 6 don't simplify any further. So there's 37, I think, is a prime number. So there's no more simplifying that. So it's 5x plus 37 over 6. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect, there we are. Okay, next thing, we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. We're asked to solve this quadratic, and we're told we're going to leave it to 2 decimal places, so chances are it's going to need the quadratic formula. And for the quadratic formula, we need to find out what a, b, and c is, or are. A is the number for the x squared. Now, it doesn't look like there is a number there, but actually there's a 1 there, so a is 1. B is the number before the x, that's going to be 12, and c is the number left on its own, which is going to be the 5. I'm going to write out the quadratic formula, but we're going to put in the values that we've just found, the a, b, and c. So the quadratic formula is minus b, and I'm going to put it into brackets. And all the substituted values I'm going to put in brackets. Plus minus square root of b squared, again put it into brackets, minus 4 times a times c. And you might ask, why am I putting them all into brackets? If they're negative, you can get yourself into real problems if you don't put them into brackets. So just put them all into brackets, you'll never make the mistake. And we've got x equals, so we're going to put this into our calculator with a plus there, and if we do that we get x equals minus 0.432 blah blah blah. Use your calculator to go back and change that for a minus, and you get the value of minus 11.567 blah blah blah. Well, that's for 2 decimal places, so that's going to be minus 0.43 and minus 11.57. The first thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well, and we've got to write that down. So we're going to say angle OBA is equal to 19x, and the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. We have a expression with f of x in, and we're given what f of x is. So what I'm going to do is just write out this expression again, but instead of f of x, I'm going to write out what it says it is. It says it is 2x plus 5. And notice I've put it in brackets as well, because f of x is the whole of that, and then plus 4. We're just going to expand the brackets, and that will make 10x plus 25 plus 4, and then 25 plus 4 is 29. So the answer would be 10x plus 29. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier. And we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. If we count the squares for 0 to 10, we count that there are 8 squares. And to get from the frequency 4 to 8, we times by 2. And so each of these will be multiplied by 2 to find out how many squares there are. But we're actually going backwards because we're going to count how many squares there are, and then we're going to try and work out the frequency. So for this second one, there are 12 squares below this line, and then these two here are 1 square. These two half squares count as 1, and these two count as 1. So it's going to be 12 plus 2, which is going to be 14. So 14 squares. Now, to get from the frequency to the amount of squares, we times by 2. So obviously the other way around, we divide by 2. So that would be 7. And counting the next squares, where it's 6 high and 2 across, that would be 12. And so we're going to divide by 2 to find out the answer is 6. So the frequencies are 7 and 6. So we can work out the frequencies of each of the groups by doing the frequency density times class width, basically find the area of each of the squares. So 0.4 times 10 would be 4. And we don't know that this is the frequency because we know that frequency density is proportional to the frequency in class width. But for this question, we're not asked to find the amounts, so it doesn't really matter. So the next one, we're going to do 0.1 times 20, which would be 2. And the last one, we're going to do 0.2 times 20, which will be 4. So if we look at less than 25, which we're looking at, so we're going to do a line at 25. So the first frequency is still 4, but this next one, the total is 2, but this bit here will be 1.5 because it's 3/4 of 2, because it's 3/4 of the area we've got. So we're going to add up the total frequencies, so 4 plus 2 plus 4, which will equal 10. Then we're going to work out the ones that we're looking for, which would be 4 plus 1.5, which would be 5.5. And so to work out the proportion, we're going to do the bit we're looking for over the total amount, which will give us 0.55. As always with this type of question, we want to get rid of the fractions or brackets if we have any. Here we've got some fractions, so we're going to start by getting rid of them. I'm going to start by copying down the question, and I'm going to give plenty of space because these kind of questions do get out of control quite quickly. And so we've got 2 over x plus 10 over x plus 10, and then we've got equals 7. So I'm just going to scroll down and just give us lots and lots of space. Put my tram lines in for the equals. Okay, first thing I'm going to do is I'm going to get rid of the fraction on the left hand side. I'm going to do that by timesing everything by x. And don't forget, it's not just both sides, you've got to times all the terms. So we're going to times the first fraction by x, which will just give us 2. Times the second fraction by x. Well, when you times a fraction by something, you times the numerator. So it would be 10x over, and it would be x plus 10. Denominator stays the same. And here it just becomes 7x. Next, we're going to get rid of the second fraction's denominator. So we're going to times by brackets x plus 10, both sides. Okay, so 2 times x plus 10 is just going to be 2 brackets x plus 10, but I can actually just expand it now. 2x plus 20. Then it's going to be 10x, because the times x plus 10 just gets rid of the denominator. And then here, let's try and expand this as we go. And so we do 7x times x, which is 7x squared, and 7x times 10, which is just 70x. Next step we're going to do is just move everything on the same side. Now, I normally keep the x squareds positive if I can. So wherever the x squared is, I move everything else to that side. So we're going to collect the 2x and the 10x, and we're going to take away 12x from both sides. So we've still got that 20 on the left-hand side, and here we have 7x squared, where is it going to be, plus 58x. I'm going to take away that 20 from both sides, because with quadratics, to solve them, we always need it to equal 0. Right, now, little hint in the question, it says, write your answer to 2 decimal places. That normally means we're going to be using the quadratic formula, and looking at this question, it doesn't look like we can factorise it. So, quadratic formula, we need to know what a, b and c is, or are. A is the coefficient of the x squared, which is 7. B is the coefficient of the x, which is 58. And c is the number on its own, which is minus 20. The quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. So, putting in the numbers, it would be minus brackets 58, and I always put brackets around these, because if they are negative, it makes it a lot easier and a lot more reliable. Minus 4 times the 7 times the minus 20, and all of that is going to be above 2 times the 7. Okay, so we type that into our calculator with a plus, first of all. So you get your calculator out, type all that out, and you should get 0.331, etc. And then on your calculator, you go back to that plus and change it to a minus, and you should get minus 8.62. Oh, hang on, that's not quite right. 8.617, blah, blah, blah. Rounded too early there. And then when you round those, you should get 0.33 to 2 decimal places, and the other one will be minus 8.62 to 2 decimal places. And looking at that, the graph for y equals sine x would start at 0, get to 1 at 90, back down to 0 at 180, then minus 1 at 270, and then 360, back to 0, and then the pattern will just repeat. So do exactly the same thing, and then end. Now, because this is minus sine of x, we're going to just reflect it in the x-axis. So instead of going up to 1, it's going to go from 0, it's going to go down to minus 1, back to 0, but then up to 1, back to 0, then down to minus 1. So it's just a complete opposite in the x-axis, just complete reflection in the x-axis. And you make sure when you're drawing it in, you make sure it's a nice curve. And really they look at the bottom to see whether it's a U shape rather than a V shape. So really just make sure you get a nice smooth curve going at the bottoms and the tops. And although it's a bit wavy, that's more than good enough to get the marks. So we're going to start by completing the square, which is asked us to do. And so to complete the square, what we do is we put a set of brackets down, and we put x minus half of the coefficient of the x, so minus 5, and square it. And if you were to expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, so we need to remove that 25. And then we've got the minus 11 there, just that was on the end there. When you tidy that up, you get minus 36. Okay, now I'm going to draw the graph of y equals x squared. Oh, I'm going to sketch it. It will look something like that. Probably a bit of a curvier bottom on that. Let's try again. So it's going to curve at the bottom and go up like that. Okay, and the bottom of it, this part here, is at the coordinate 0, 0. Okay, now we remember, hopefully, from graphic transformations, is if you have got a minus 5 on the inside of a function, and if we imagine that this is our f of x, then this would be our f of brackets x minus 5 because it's got the minus 5 there. We move the graph to the right 5. Remember, it goes the opposite way. So if it's a minus 5, it goes to the right. If it's a plus 5, it would go to the left. We also know that if you have a minus 36 on the outside, which we do here, it moves it down 36. So it's going to go down 36. So our new minimum point won't be at 0, 0. It will move to the right 5. So the x coordinate will be 5. And it will be moved down 36. So it will be minus 36. With this question, we're going to first of all have to find a length before we can find the length AF. And it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of a squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117. And then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angled triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals AF squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.